All right, so on assignment number 5, we're going to be converting between degree measure and radian measure. And then we're also going to be finding arc length at the end of this. And so let's go ahead and get started specifically with some ones that we should know based on what we did yesterday, which was completing that unit circle. If I have 180 degrees, we should know that that is pi radians. If you remember, on our unit circle, we had that this is the radius, 1 radian, 2 radians. It takes exactly 3.14 radians or pi radians to make 180 degrees. So this is going to be a key thing for us to remember throughout this lesson. So let's go on to number 2. If we have 135 degrees, well, if we know that 180 degrees is pi radians, well, then 135 degrees is how many radians? We can set up a proportion to solve this, and then to figure out what n is if we cross multiply, we know that here I'm going to take 180 times n, and that's going to equal 135 times pi, which is the other cross product. And so to figure out what n is, I'm just going to divide both sides by 180. And so if I take 135 times pi divided by 180, I could actually simplify. I could simplify the 135 over 180, and that would give me 3/4. So 3 pi over 4 radians. And usually we leave radians in terms of pi. Now I could actually multiply 3 times pi divided by 4 and get some as close to 2.356. But normally we'll just leave it in terms of pi, just like we did on number 1. And 135 degrees is 3 pi over 4 radians. Well, what about 330 degrees? Well, let's set up the same proportion. If we have 180 over pi, that equals 330 over what? So I could cross multiply. I'm going to skip this step here and just have n equals the 330 pi over 180. And all I'm going to do is simplify the 330 over 180. That's the same thing as 33 over 18. If I divide both of those by 3, I'm going to have 11 over 6. So 11 pi over 6 radians. Now we can also look and find those two on your unit circle. So you can find the unit circle and find 135 degrees. That corresponds with 3 pi over 4. You can also find 330 degrees, and that corresponds with 11 pi over 6. So you don't have to do the proportions to solve those, but you can on these. Let's take a look at these 4. And I'd have you pause the video and try these 4 completely on your own, and then start the video and see if you had them correct. So with number 4, you can actually do this by converting it. Take 360 minus 120, which would be 240, and find the 240 degrees. Or you can just set up the same ratio and do it with a ratio. I'm going to go ahead and think of the unit circle. And what I'm doing is going 120 degrees backwards in this direction. That would put me at 240 degrees. And so 240 over n is equal to 180 over pi, because we know 180 is pi radians. So if I cross multiplied, I would have n equals 240 times pi divided by 180. Well, 240 over 18. Let's see, 24 and 18, 6 goes into both of those. So that's going to be 4 over 3 pi radians. So that's 4 pi over 3 radians. And that could be done by also using your unit circle. 510 can also be done using your unit circle. That's 150 more than 360. So you can go around 360 plus 150 more and figure out where that's at. That's the same thing as 150 degrees. And so I'm going to put 150 over n is the same thing as 180 over pi. And if I cross multiplied, I would have n equals 150 times pi divided by 180. And that means if I divide the 15 and the 18 by 3, it's going to be 5 pi over 6. So this is 5 pi over 6 radians. Let's keep going with 6 and 7. 6 and 7 are the first two that are not on your unit circle sheet. And so if I just start with this proportion that we know, 180 is pi radians, so 160 is how many radians? And so I'm going to go ahead and multiply 160 times pi and divide that by 180. And then the 16 over 18 reduces to 8 over 9. So this is 8 pi over 9 radians. 100, same thing. I'm going to take 100 times pi divided by 180. And that's the same thing if I cut those both in half, the 10 and the 18, it's going to be 5 pi over 9 radians. So that's a real quick example, some examples of changing degrees to radian measure. Let's move on and change these radian measures to degrees. And so we can think about this the same way. We know that if I have pi radians, that's 180 degrees. Well, here I have pi over 3 radians, and that's equal to how many degrees? It's proportional. I want to solve this proportion. And if I solve this proportion by cross multiplying, here I would have pi times n. And if I multiply these together, I'd have 180 times pi divided by 3 radians. Well, the first thing that I could do is divide both sides by pi. So the pi's are going to be gone. So it's just going to be 180 divided by 3. And so n equals 180 divided by 3 is 60 degrees. And so pi over 3 is the same thing as 60 degrees. Now this could get a little shorter here. If I do the same thing for number 9, by the way, you can find this relationship on your unit circle. Now 2 pi over 5 is not on your unit circle, but we can set up the same relationship. Pi is 180 degrees, and so then we have 2 pi over 5 is how many degrees? And I want to solve that for n. So I'm going to take n times pi equals 180 times 2 pi over 5. Now I didn't put the pi's in there because if I divide both sides by pi, they're just going to cancel each other out. So I'm just going to take 180 times 2 divided by 5. Well, 180 times 2 is 360. 360 divided by 5, I believe, is 72. So that means that n is 72 degrees. And that is something that's not on your unit circle, but we can find by just setting up a proportion and solving it. 5 pi over 8. Well, again, I know the relationship that pi is 180 degrees. So 5 pi over 8 is how many degrees? So that means that it's going to be 180 times 5. Well, I don't need the pi, so times 5 over 8. And so 180 times, I'll do this on my calculator, 180 times 5 divided by 8 is 112.5 degrees. And then as we get going on this, we probably don't need to set up the proportion because what we're doing is we're just taking 180 and sticking it in for the pi. 180 is pi degrees, so I'm just going to take 180 times 13 divided by 10. And so then 180 times 13 and then divided by 10 is 234 degrees. So this is another one that's not on your unit circle, but it's 234 degrees. All right, let's take a look at this last problem here. We're going to find the arc length from A to C, that distance. Here we have the angle, which is 45 degrees, and the radius is 3.5. But if you remember when we talked about this, the radius here is 3.5 degrees, and if we take that radius, it's going to take 3.14 of those radiuses to get halfway around the circle. And so 45 degrees is pi over 4 radians. And so that means it's going to, if I was finding this total arc length here, I would just take 3.5 times pi, because it's pi, or 3.14 of those 3.5s that gets me from C all the way to halfway around the circle. Well, this is a fourth of that. So all I'm going to do is take 3.5 times pi, which would give me the distance halfway around the circle, and then divided by 4, which is the arc length from A to C. And so if I take 3.5 times pi and then divide that by 4, that arc length is 2.7, close to 2.75. And that would be the length from A to C, 2.75 feet. So there'll be things like that on our homework as well. But this is what we're doing for tonight, specifically converting between degree measure and radian measure, but then also hoping that we can answer some different questions about what radian measure really means. So good luck on that, and we'll go over questions tomorrow that you have in class.